So today we have a workshop convened by Dr. Forbes, Dr. Habib, and Jessica Mostacito on the Food-Energy-Water-Nexus using Hydroviz to support undergraduate student learning. This is going to be a 2-hour workshop. Thank you for joining us today. Before I hand things off to our speakers, I'm going to give a brief overview of Quasi while we're still getting settled. My name is Julia Masterman. I'm the Education and Outreach Specialist for Quasi. Quasi is a consortium of universities for the advancement of hydrologic science, and we're a nonprofit organization funded in part by the National Science Foundation. Our mission is to advance water science by strengthening interdisciplinary collaborations, providing critical infrastructure through our data services, and promoting education in water science at all levels. We seek to fulfill this mission in a couple ways through our data services and our education and outreach services. Our data and compute services provide support for the entire data lifecycle, from data discovery all the way through archival publication, with tools and support along the way for data sharing, visualization, and analysis. Lots more information on the website. Feel free to reach out if you're interested. The other side of our house are our community services. These include grants, workshops, and a summer institute. Webinar series like this one, workshops, a guest lecture database. We also have a hackathon coming up, plenty of things going on. I want to highlight a couple of upcoming events quickly here that may be of interest. Firstly, we have a fellowship and grant opportunity that's accepting applications right now until February 1st. So that deadline's coming up quickly for the Hydromatics Innovation Fellowship. However, we will be opening applications for 2 other funding opportunities soon. That would be for Let's Talk About Water, which is a science communications program, as well as another instrumentation support grant. So keep an eye out for plenty of funding opportunities coming up soon. Another event that we have coming up this year is our biennial colloquium. This is a small scale conference, all welcoming everyone from the Quasi community, which is everyone involved in water science. The call for workshops and breakout sessions is closing very soon on February 1st, but also very soon this week, we hope to be announcing a call for poster presentations and other presentations at this meeting. So if you're interested, keep an eye out for that opportunity as well. As this webinar is primarily focused towards educators, I definitely wanted to highlight this opportunity. The Quasi Virtual University is an opportunity for professors to teach a module or a course to students across the country. This is part of a larger program, and the call for instructors is now open. So if you're interested in becoming an instructor for the CVU, visit our website to learn more, or reach out to me or to my colleague, Veronica Sosa Gonzalez, who leads that program. And more broadly, if there's a specialized topic or method or tool that you've created that you want to share with the community more broadly, whether that be through a webinar series like this one or an in-person workshop, please reach out. We're here as a service to the water science community and would welcome the opportunity to potentially work with you. And with that, let's kick things off for today. A few logistical notes. This webinar is being recorded and will be posted on the Quasi YouTube channel in the coming days. Secondly, we ask that you use the Q&A functionality to submit questions to our speakers. That way we can get to as many as possible. Finally, we expect that all involved with Quasi Cyber Seminars uphold the Quasi Code of Conduct and promote and maintain a professional, considerate, respectful, and collaborative virtual environment. Thank you again to our conveners for putting together this workshop and for taking the time to join us today. Thank you to all of you for joining us as well. With that, I'll pass the mic on to our first speaker for today, Dr. Habib. Thank you.
Yeah, good afternoon, everybody, and thank you for the opportunity to share this module with you. Sylvia and Corey are the primary developers of the content, the educational content, and myself here, Imad Habib at the University of Louisiana. We provided the Hydroviz platform that the module is built on. And I think Jessica we'll go through a lot of the details, but I just wanted to kind of give you a very quick background about Hydroviz, how it came about, and what you can do with it in general, and then turn it back to the program here for the module itself. That's what you came for. So I'll share just a couple slides quickly to, like I said, give a very quick background about Hydroviz and sorry here. Okay, so this is Hydroviz is a science foundation, National Science Foundation grant that goes back several years, and it started as developing several learning modules around case studies in different parts of the country, and then as part of that, we also developed this Energy-Water-Nexus module, or which turned into a platform that the module that you're going to cover today is built upon. Just like I said, a very quick overview of the history, just acknowledging the Science Foundation support that goes back to 2008, actually, with several grants focusing on developing modules through the Hydroviz platform, and then closing with the last grant that we had from them on developing this HydroLearn platform, where it basically allows people to develop their own content around case studies or around data sets and models that and then share with the community. And I think the module that Corey and Jessica developed is an example of that. If you want more information about the original module and the tool that sits behind it, we have an article that was published in 2017 in the EOS newsletter through the AGU. You can read it there. You can get an idea about the type of activities that the students can do with the data. And we design it with looking after the student outcomes and how they are informed by Bloom's taxonomy to make sure that the outcomes are measurable and achievable. The platform has a lot of data that you will get to interact with today, primarily water data and energy and agricultural data at the HUC 12 scale, if you're familiar with that. Just to give you a very quick overview of the site, let me actually, can you see our website now? I'm sorry if I'm sharing, or let me make sure I share the website itself. Okay, so this is the platform or the tool, the Hydroviz tool for energy, and it started as energy and water, really Nexus, but then working with Corey and Jessica, they added another dimension to the tool, which talks about the agriculture. And the tool is pretty self-intuitive, but I would just bring your attention to a couple things. You can toggle back and forth between this and the map. You'll probably be working mostly with the map today. This is the usual stuff. You can turn things on and off. There are these two primary layers. The one where you interact with the water data at the HUC 8 scale. I'm sorry, I misspoke. It's a HUC 8, not HUC 12. And then there's also power plants, a layer where you can interact with a specific power plant. So, the way you interact with the map, is basically you have to activate a layer, and then the I button here will allow you to click on a certain HUC. And by doing that, there might be a lag if you are the first time you visit the website, but it should actually give you a list of the variables that you can see for each HUC throughout the country. Again, you'll get to interact with it throughout the day today. It's primarily, data on mean annual flow, surface water consumption and surface water availability, groundwater components. And then it gets into also some of the agriculture parameters, the land in farms and acres, and the irrigated lands, market value. Again, you'll get to interact with this data today. I would like to point your attention to, once you activate the layer with this I button, if you want to interact with the data itself, you can actually need to click on that camera button. And then here you can do some filtering. Let's say I'm interested in Alabama. And I'm interested in a certain variable. They are grouped here by surface water, groundwater, non-potable resources, and so forth. Let's say I'm interested in that. I can allow you to do some basic displays to the interface. You can see it here. It's highlighting Alabama now. And then you can also interact with other variables that you have, and you can filter and things according to your needs. You can download the data if you want to. You can download whatever data that you filtered here. It will download it into a CSV file. You can do the same thing for these individual power plants. You just have to activate the layer for that. And let's say I'm interested in that power plant here. I can click on it. Again, if you are the first time to interact with it, it may take a few seconds or so to pull the data. But eventually, it will show you that power plant, what kind of fuel it's consuming, and so forth. So you can get a lot of the data from there. So it's pretty interactive. And I guess, like I said, Corey and the group, we had a joint project. Again, Jessica will provide feedback on that, where they built a module that uses this tool, and they deployed it onto HydroLearn, which is the other project that we also lead here at the University of Louisiana, to basically allow people to build modules and share them with the community. An example of it is what we are doing today, actually. So with that, I'll stop and hand it back to Jessica to walk us through the module that we are here for today. I'll be happy to answer any questions about Hydroviz or HydroLearn in general. You can email me or you can chat with me throughout the presentation. But thank you again for your interest.
Thank you, Dr. Habib, for your presentation and for the introduction to Hydroviz, and also Julia for the introduction to the workshop. I will share my screen now to continue with the presentation. So let me. All right. As Dr. Habib was mentioning before, so we have developed a module using Hydroviz. And today's presentation is the Food-Energy-Water-Nexus, using Hydroviz to support undergraduate student learning about complex socio-hydrologic issues. At this moment, Dr. Forbes is in a meeting and will be joining us after he completes that, so he will be in a few minutes. So the topics that I am going to present today are basically the objectives of this presentation. I'm going to briefly talk about the project, like to provide you more context about where this presentation is coming from. So I will be talking about the course that we implemented with undergraduate students and how we use Hydroviz within this context. I'm going to introduce the curricular module in Hydroviz. We will do several exercises using Hydroviz. So you will be working on your computers, engaging with the tool. Also, I'm going to give an introduction to the decision-making framework, which is what we have used to analyze a case using the tool. And you will also be engaging with this decision-making task. And to finalize, we are going to do a wrap-up, and also you will continue with the workshop evaluation. Something I want to mention at this point is I thank you very much for submitting your responses to the pre-survey. This is a very important tool for the evaluation of the project. And if you haven't completed it yet, please take this time. And also we will give some minutes so you can complete the pre-survey at this point before we start doing the exercises. So the objectives of this workshop are two. First, we are going to identify the core contents of the course module, and then you are going to be able to get ready to modify and be prepared to implement an adapted version of the module in your own courses to effectively support the students' learning. With regards to the project, so between 2017 to 2021, during the spring semesters every year, at the University of Nebraska in Lincoln, we had an undergraduate course called Water in Society. So within this course, students were taught about core hydrologic concepts, and they engage in different active learning activities, and it was developed using effective STEM instruction. So our students were able to participate using real world scenarios. They use different kinds of tools to use data to make decisions about different kinds of systems. And we also try to help them to learn more about systems thinking, how different systems related to water interact with each other. And these were part of several projects that were funded by the NSF IUSE, also the USDA, and the Doherty Global Institute at the University of Nebraska. Here you can see a link. So if we click on this link, you will be able to see the different studies that are related to this Water in Society course. A lot of people participated in the development of the course. So Corey Forbes has been the principal investigator for all the studies that were part of the course, of the Water in Society course. Nick Brozovic and Dr. Franz, they also taught the course. I mean, they were part of the teaching team, and they were also part of the research that was conducted. Dr. Habib has joined us, as he explained, through the Hydroviz project. Diane Lally, Destiny Petit, Holly White, and myself, we have been graduate students who have participated at different stages of the course. Myself, I started working in, I was in the last iteration of the course in 2021. And Jenny Bird, she is from the University of Louisiana, and she has helped us reviewing the module and also making it available in HydroLearn, also with Dr. Habib. So the course objectives of the Water in Society course were for students to be able to explain fundamental hydrologic concepts and use this knowledge to engage in scientific practices, including posing and answering scientific questions, exploring hydrologic phenomena, analyzing and making inferences from data, and determining validity of conclusions. And the second objective was for students to be able to engage effectively in principled analysis of and reasoning about socio-hydrologic systems, including their scientific, ethical, social, economic, cultural, and civic dimensions to be able to make informed decisions about water resource use. So among the things that the students did, so the course had different modules where they were able to use different kinds of computer-based models and simulations, where again, they were learning about hydrologic concepts. They engaged in different activities where they evaluated aspects related to the economy and policy and social and cultural aspects of water resources. Different experts, scientific experts also from communications and industry, were able to join the course at different points and help them with their different perspectives. They use a structured decision-making framework to be able to propose solutions to local, regional, and global water challenges. They participated in different site visits and field trips to local municipal water facilities. The course was very interactive, so they work in small group teams to conduct independent research, and they were able to present coursework to scientists, policymakers, and stakeholders at the Water for Food Global Conference at the University of Nebraska. These are some images about some of the activities that I was mentioning earlier, some of the group activities that students held, and this was in pre-pandemic times. Also some of the poster presentations that they had and some of the field trips undergraduate students did. In terms of the characteristics of the students, well, we had students who were, I mean, in general, undergraduate, they were freshmen, sophomore, junior, and senior. And in this table, we can see that they were distributed among all these different groups. So it was an introductory course, but we have a very diverse group. And we can also see that in this other slide where we can see that we had students from STEM and non-STEM majors. And also, well, during the first 4 years, we had around 60 students per year, but on 2021, when the course was fully asynchronous, we had an increase of the number of students close to 115, close to 120. So thank you. That was a brief introduction to the course. So to give you a little bit of an idea of where it came from. So that course had different modules, and one of them was related to the food, energy, and water nexus, where we use Hydroviz. So that's the module that we are going to talk more about today. On this link, we have different things that we want you to look at. Once again, this is the link to the pre-survey. Please complete it if you haven't done so already. This other link is the access to Hydroviz. So these are bit.ly links. So I will open it here. So we have it available. We have a tab available. And we will start working on it in a little bit. These are instructions to access the module. So if you click here, and this is bit.ly/FEW-module. If you access that, it will send you to these instructions where you will be able to create an account in Hydrolearn and also gain access to the module using using Hydrolearn, I'm sorry. And then we have this other folder. So this is also a bit.ly link. It's HBZ folder. So if you access this, you will be able to see these 3 files. This one, which are the instructions that I showed earlier. This is the presentation I am currently giving. And these are workshop exercises. This is a template. So you can actually open this one here, which I think is the one that we are missing. You will be able to see here, you can download this template. So we are going to be inputting some of our responses here. So, and I am putting some links that are of interest. So for instance, the link to the pre-survey, so you can access it more easily here. These are the part for the exercise 1, so the link that we are going to use and some of the activities that we will have. This is for exercise 2, so the access to the links that I will put in the presentation and also the numbers of the questions, and for exercise 3 as well, and then exercise 4. And the last link, which is for the wrap-up and evaluation, which is the post-survey that will come later. Okay, so that's this part. So we will take a few minutes for everyone to gain familiarity with these links, to complete the pre-survey if necessary. So right now it's 1:24. So I think that by 1:30, yeah, that would be good, give us like 6 minutes. By 1:35, we will continue. If you are completed with your with the pre-survey, please let us know. So we will stop here just for a little bit, so you can access all these links. Once again, we are currently in this slide where you will have access to different links, and we were asking for participants to be able to complete the pre-survey, which is the first link, and also to open the other 3 links to have access to Hydroviz, also the instructions to create an account to in HydroLearn to access the module, and also to download the exercises sheet in the folder. We will continue at 1:34. So a couple of more minutes for people to complete and to continue with the presentation. Okay, we will continue now. Thank you very much. So now we will start working with Hydroviz. So to continue, when we think about watersheds, this is an area of land where all flowing water converges into a single point. So we have here an image of these different bodies of water, and the watershed divide, so we can see how water is going into that lake or reservoir. So the USGS it has set a nationwide system for identifying the different watersheds in the US. And it uses a system which considers the hydrologic unit codes. So this is a sequence of numbers that identify different hydrologic units. So there are different sizes. So for instance, a HAC2, so we have the different digits over here. That one would refer to a region. Then HAC4s are the subregions. The basins are HAC6, and then the subbasins are HAC8s, and then we have the watersheds, which are smaller, and they are HAC10s, and then we have subwatersheds, and they are HAC12s. So we can see in this part of the slide that each one of them have different sizes. So when we are thinking about HAC8s, these have in average 700 miles. So over here, we can see a map of the US, and we can see the different regions. So these correspond to the HAC2s. So in average, they have 177,000 miles. And when we consider Hydroviz, so the delimitation or the hydrologic unit code that it considers are the HAC8s. So for instance, here, for this subbasin that has a form of a little cow, it's called Middle Brazos Palo Pinto, and its identification number is 12060201. And what we can see here is that it has 8 digits, and that's the name to which the ID to which it is referred. So we will remember this image because we're going to work with it more in the next slides. Other things that are important to consider. So the area is in acres. The flow rate refers to million cubic meters per year. And the water stress ratio is the fresh water withdrawal as a proportion of available fresh water resources. And here's one of the equations that is used to calculate that. So in Hydroviz, in the next slide, there is more information about these different the different ways in which each one of these parameters were calculated. So we can see them there. So now we are going to start working on the first exercise. So we are going to respond to a couple of questions. So first, we are going to choose an HUC of our interest. Previously, I showed you the Middle Brazos Palo Pinto, so we are going to try to find it. You can also work with another HAC8 of your interest, but it would be useful if you follow us, and maybe you can identify the answers using Hydroviz for that other location that you're interested in. We are going to choose the HAC8 of our interest. We are going to find the total water availability in that HAC8. So we are going to see the groundwater recharge and also the mean annual flow. Then we are going to see how many acres of land are in farms in that HAC8 and what kinds of energy types are produced in the HAC8. So we are going to start with the first one, choose an HUC 8 of our interest. We are going to go to the link to access Hydroviz. So we have it over here. If you don't have it already open, to the bit.ly/Hydroviz to ease access to it. We can see here, as Dr. Habib mentioned earlier, like the general view of Hydroviz. This is some additional information about the portal, and so some things that you can see here that provide general descriptions about what you are able to see, how the data is displayed. Oops. My apologies. Okay. Acknowledgements, references, and also authors. Sorry. Okay. So I will hide this for now. And we can see here, so we have the different layers. I will turn off this over here so you can see how what happens if you turn on and turn off some of these layers. Our first question was trying to identify the hackade, the name of the hackade. So I will turn on this one, but you will see we are trying to see where that is located. So if we go back here, we can see that we have the map of, Texas over here. So we are interested in going to Texas and then finding this location there. So to be able to do that, we are interested in turning on a layer called the states. So we can see here in the base layers, we have the major rivers, the major basins, the streams, the states, and the counties. So again, we were interested in finding Texas, so we are going to turn on that one. So we can see that it is difficult to see it right now, but something that we can do is to click here on HUC water data and move it below the states. Okay, so we can do that. So now we are able to see that the states layer is appearing on top of the HUC8 water data layer. We can zoom in over here a little bit. Okay. So here we have Texas. Okay. And this shape is familiar for us. So this is the one that we were trying to work with. And again, you can choose another hackade related to maybe the state where you work in or where you want your students to find more information about. But for now, we are going to focus on that one. So in order to be able to find information about water resources in this hackade, we are going to click here on top of the information feature. So you see it is orange now. And we are going to click on top of the subbasin. Okay, so we have a lot of information here that has appeared. We have the name of the state, the hackade name, the ID. So these are the 8 digits that I mentioned earlier, the acres, and also Dr. Habib mentioned it in his presentation. So we have the mean annual flow, different characteristics of surface and groundwater, also in relation to what kinds of uses there are, and the information about the water stress, and also information about agriculture in that region. So we will leave this there for now. We have our first question here, which was choosing an agency of our interest. So we chose one. And the next question was to find the total water availability in your hackade. So we will look for the groundwater recharge and the mean annual flow in our table. So first was the groundwater recharge. So we can find it over here and we can highlight that and copy it if it is, to ease the process. And we can come here to the workshop sheet, and over here you can put the name. We can put the name of the subbasin, and here we can put here Middle Brazos, Palupinto, and over here we will put the information about the groundwater recharge. Yes. Okay. Then the next one is the mean annual flow. So if we continue looking here, we can see over here the mean annual flow. So we will also put that, we will copy it just with Control-C, and then we will paste it here. And we have already included the formula here. But one exercise that you can do with your students, if you're interested in them practicing with Excel sheets, is to actually make them work on it and create these different formulas so they can learn about that as well. So we have that response here then the next question is how many acres of land are in farms in your AGC8? So acres of land in farms. So we will look for that. If we go to the part of agriculture, so we have land in farms in acres, and we will also copy this information here. And we will put that over here. Okay, we will keep it there. And then we have a different kind of question. So right now we had questions about water resources, about agriculture, and then now we have a question about the energy types. So what kinds of energy types are produced in your AGC8? Okay, energy types. So if we go back to Hydroviz, we see we have information about water and also about agriculture, but now we need information about energy. So I will close this for now. And then, okay, we can see here, we have a layer called power plants, and we need to turn that on. Okay, so I click here in this white box. So now we can see the different power plants, the different power plants in all the US. And we are going to find the different characteristics of them in the AGC8 of our interest. So similar to what we did with the AGC8 water data, I will click here in the identification information icon, and I will click on top of one of them. So for instance, we have the plant code, the plant name. So the primary fuel, so we have natural gas, we have the total capacity, energy generated, and the cooling type. So our question was about what kinds of energy are produced in the AGC8. So here we have natural gas. So that is one we will put here. So natural gas. We can see that there are other plants, and I will make it a little bit closer. There you go. To use this. So if we put here, we can see in this other plant, their primary, the energy they produce is wind energy. So I will put it here as well. We have natural gas again, wind, natural gas, maybe see this one, another one with wind, and okay, so now that's natural gas. And that's natural gas again. So basically in this region, there are two main energy types that are produced. So those are natural gas and wind. If we go back to our presentation here, so in this slide, we have the responses, which are basically the same ones that we have here. So let me see, we will take maybe some 3-4 minutes, so for you to be able to engage with the tool and to respond to these questions on your own, so you get more familiar with the tool. So we will do a little bit of that, so we will wait. If you have any questions, please let me know. Please put them in the Q&A or in the chat, so I can revisit some of the things that I did previously. So yes, until 1:55, I will continue with the presentation. All right, so just let me know if you have any questions, and I can repeat some of the steps that we went through right now, so we can continue remembering them. Okay, so we have a question. I am not able to edit the Excel doc. Could you please let us know if you downloaded it? So let me put it here. If you download the document, if you put it like in Microsoft Excel and you open the file, let me see if there is. Okay, so probably it's appearing like this. You can click on enable editing and you will be able to open it. Please let us know if that helped solve the problem you were having. Let's see. So Dr. Habib was saying that we can also filter the data by fuel type and display on the map directly. And we can also, and he can show, Dr. Habib, if you want to show that, I can stop sharing my screen for now, so you can show it.
Sure, I'll be happy to do that. So just some simple ways to filter things and maybe download the data also. So for example, here on the power plant, I can, like Jessica was showing here, I can query each individual power plant, but I can also, if I turn on this camera button, I can actually go and say, show me all the power plants that have coal in them, or natural gas, NG here, or geothermal, or so you can select that. And once you do that, you can also color code them by the amount of energy they generate, the total capacity, for example, here, and I can display it nationally. So it will color code. Let's say if I'm interested in Texas here, I can see what type of power plants I have in each state, and this way I can actually get a visual of them. If I'm interested in something specific, that I can download it, right? So it will download into a CSV file that you can work with. So you don't have to copy and paste the specific values. Same thing if you go to the WAR data, and I can also look at a certain state, let's say Texas here. If I'm interested in Texas, the same example that Jessica was showing. And now I can select even a HUC 8 by itself if I know the name of it, but if not, I can also download the data for that particular state. So, and I can download it into a CSV file, you know, whatever the name is, and I'll be able to download it locally as a CSV file. So you can do that stuff besides interacting with the data on the website itself, but you can download it on Excel or a CSV file, and it will come with all the variables. You can download the data for the entire US, actually, if you want. Everything that you see on the website, you can download it here by clicking onto, instead of one state, you can select all states. It will take a minute or two to do that, so you just have to be patient, but you can literally download every variable that you see on the website here. You know, like I said, it will take a little bit, but it will give you all this data, whether it's the mean annual flow, the groundwater, the surface water, the water stress, the ag, everything you can download onto CSV file, and you can do anything you want with it offline. So just kind of wanted to show you that visualization on the interface directly, but also downloading to work off. And you can filter by states, by variables, by HUC name, by anything you want. So you can just basically slice and dice the data the way you want. So. And I'm going to stop share. I don't know how to stop share somehow. Yeah. Okay.
Thank you, Dr. Habib. Well, it seems we don't have. Well, we had 2 questions, but it was about the access to Excel, but those were addressed. So I think I will share my screen again so we can continue with the presentation. So my screen here. Okay. All right. So we again we did the first exercise and we started to engage with Hydroviz. Now I will continue explaining more about the module. So we have the curricular module, which is about the food, energy, and water nexus. So there are different characteristics of the module. So first, what you will be able to find in HydroLearn is this image or figure where we can see like first the introduction to the module. So in this part, what you will be able to find is a general description of the module, the learning goals. Then we will be able to see the introduction to the FEW-Nexus. So in that part, we are explaining about general characteristics of the FEW-Nexus. We are also explaining about Hydroviz. Students can do some of the exercises with Hydroviz already. Then we are going to introduce in that section the overall characteristics of the project that the students are going to be engaging with. Then we have the water and food component of the module. So here we are seeing the relationship between water resources and the production of food. Both globally and also in the US. And in this part, the students are going to be participating in the second part of the project. So then we have this third part, which is the food energy and also the water energy nexus. So in this part, we are seeing how energy is needed how water is needed for energy production, and also how energy is needed for different processes related to water resources. And then we also see how energy is needed for the production of agriculture. And here we are, students are going to engage in the third part of the activity. So this is like this part of the module, but we also have a scenario again. So the students are presented with a real case scenario where they are going to try to address an issue that has technical and also social components related to water resources, energy, and also agriculture production. So we have our students using Hydroviz in these three different parts. So the first part, they are going to use Hydroviz to find information about the FEW-Nexus in the region. Then they are going to engage in a second part where they are going to find more about agriculture production. Then in the third part, they are going to see more about energy production in that region. And in the fourth part here, we start by providing students information about how to engage in a systematic decision-making framework, using first a familiar case, then a case related to the socio-hydrologic issue. And then with all the information they have gathered from Hydroviz, they will work on part 4 of this project, where they will do the same exercise with this decision-making framework, but with the scenario that they were studying. So this is just a general overview of the module. What you will be able to find in HydroLearn is different sections and subsections and units. So here we have the food, energy, water nexus. These are the main sections that I was referring to earlier. So if we access, for instance, the introduction to the FEW-Nexus, some of the things that we are going to be able to see are the summary and learning goals, introduction to the FEW-Nexus, introduction to Hydroviz, and also to the first activity using Hydroviz and some resources. So we have in the summary and learning objectives, basically a description of that section and also the learning goals. We have different activities that are part of that section. We are also able to see some presentations. So we have some videos in HydroLearn that are part of the module. So you will have access to the slides and also to a handout. And that all of these are available for download, and your students can use them. Then we have also some quizzes within the module. We have a list of resources, so the different references that we use throughout each of the sections are here, and we have the different links to all of them. One thing that you can consider is perhaps removing these links, so you can ask your students to look for these resources by themselves. So in that way, they can learn better how to locate information within, in different websites, right? So that is something that you can do. We are providing instructions about Hydroviz, so the project over here, what they will be doing in each one of the parts, more information about Hydroviz. They will present it with a scenario that I was mentioning earlier, and we are going to touch more on that in further as we go through the presentation. Then the first activity, so we provide very specific instructions as to what to do once they access Hydroviz, where they need to click, how they need to move things around so they are able to find the information. And in that way, they can start working on each of the parts. So the part one of the assignment was to explore a region. So in this first part, our students are trying to find more information about the water availability and stress in a region that they chose. They also find more information about the energy generation in the region, and then the information about agriculture production. And we can see here that we have some questions. So for instance, the first is to choose 2 to 4 adjoining HUC8s in our selected area, list their names, and also find information about the mean annual flow and groundwater recharge, and to find the total water available in the entire region. So as we can see until now, this is basically what we did in the first exercise. And we can see that there are more questions here that we asked as part of this first part of the assignment. But the idea is for you to also to be able to experience what your students would be experimenting once they are starting to work with Hydroviz. So this is like the first part of the activities. Let me see yes. So here we have other questions. These are related to energy resources, and again we have worked a little bit on that, but we have more questions that are specific to energy production. And we also have questions about agriculture. So here we are asking about the landing farms in the HUC8, and yes, other questions that are also related to agriculture production. So I have a question here in the chat. It asks, is there any chance that Puerto Rico will be added to this Hydroviz? And perhaps that would be a better question for Dr. Habib.
Yeah, I'm reading the question. So if you have the data, yeah, it's a good question. So when we built the Hydroviz tool, we built it nationwide, and we relied on some of our own analysis in terms of figuring out the water resources and power plants and all that stuff. And we gathered some national data sets, and definitely if the data is available for Puerto Rico, we can add it to the tool. So I'll just have to go back and look because some of that data is not something that we generated. We worked with the Sandia National Lab, and they shared with us the power plant data sets, and so I can go back and look at those, and if they are available, we can certainly add them to the interface. I don't know why we would have left them in the first place if they were available, but you know, Puerto Rico is, yeah. I mean, we'll check on it and see if we can add it. And I guess there's another question. Can you demonstrate how to calculate the water stress ratio from the given surface and water groundwater data? Jessica, I'll let you answer that unless you want me to help with it. I mean, there is a, go ahead.
No, please, you can continue. I can show it here, but yeah.
Right, so this is actually, you know, if you can allow me, or you go to the table of contents, if you don't mind, expand the table of contents.
Okay. Oh, I can.
No, on the left side, All right. If you, right, here you go, right. And then you see how is water stress calculated? You see that 1.3? And this gives you just a very detailed, I mean, you know, not too long or anything, just a way to calculate the water stress. And these variables are available on the platform, on the tool, right? So, you know, just if you read that, it will tell you, once you download the data, you will also find the variables, right? If you are interested in a specific state or a watershed, you can download the data into a CSV, and then you know, you know, so if you use the camera button, I guess she wants to see how, or you ask the question is how to calculate that stress ratio. If you use the water stress button, sorry, the camera button at the lower right side next to the eye. Right, here you go. And let's say select a state and click the state that you're interested in. And you can download that data altogether, even if you don't write down. If you select a variable, that's fine. If not, you can download the data. You can download a CSV file, right? Just anything you want, really. And when you open it, it will come, hopefully. Yeah, so here you go. Right, so because there were some watersheds that are between Texas and Arkansas, and between Texas and whatever, right? So you get every watershed, you get all the variables, right? Every column here is one variable, and then you can use the formulas that I showed you on the Hydroviz, right, to calculate. If you can go back to the interface again, right, exactly the lesson, right. So these are the variables that you need, right? So for example, CSW, that's the surface water, CGW, that's the groundwater, and so forth, and the environmental factor. Once you read that, you will. It's very straightforward. You plug in the data in the same CSV, and you can calculate the water stress for that. Did that answer your question?
Yes, I think. Okay, so I think yes, and also with regards to the other, yes,
yeah,
they said thank you. And another thing, yeah, sorry.
No, I was going to say that if Robin, if you want to follow up with me after the webinar, I'll be happy to talk to you about it. It looks like you did some work on Puerto Rico, and maybe there is something that we can do there, or maybe it's not. But if you want, feel free to follow up with me offline, and we can talk more about it.
Okay. So I think I will continue with the second exercise. Thank you, Dr. Habib. All right, so for the second part, in which students are using Hydroviz, previously we identified a region, and we started exploring about food, energy, and water in that region. Now we are in the second part, we are going to work more on the agriculture portion related to that region. So they are going to engage in questions where they will be asked about the different, how water is used in that, for the different agricultural products, also the monetary value of agricultural production, which are the commodities, and these different footprints of water, land, and carbon footprint related to agriculture in the region. So here we have also what you will be able to see in HydroLearn once you access the module. And now we are going to work on the second exercise. So again, we have our Excel sheet. So we are going to first find which are the counties that are in our AGC8. So we are going to do that first. Okay, we are here. Let me close this. All right. So here is the AGC8 that we identified. And now we are interested in knowing which are the counties that we can find here. So if I go here to the layers and I click here, I will be able to see that we have that the counties layer appeared. And now if we select this button again, the I button, we can click on top of them and we can see the names of the different counties that we have. So one of them is Palo Pinto. And we can go back here. So again, here, okay, sorry. So here we have the option. So I will put here Palo Pinto for our second, for the second exercise. And then we have others. So I will put here, I will click here, it's Stephens. We have Young. Stephens, Young, Jack, Parker. You see, there are several that are intersecting with our AGC8 and Hood. So only for the purposes of this exercise, I will mention Palo Pinto and others, but you can write down the names of the others or ask your students to put all the names of the other ones. Okay, so that's like how you can identify the counties in the AGC8. And now we are going to move into the second activity here in the exercise 2. So we are going to look at the USDA data. So we are going to access this bit.ly link. And then, so let's do that first. And remember here in the workshop exercises, you have the links of interest. So you can click on the second one here for the USDA data. So I will access these, okay. So it is asking us to select our state and then table 1. Okay, so we will be able to see this web page, which is from the USDA, and it has information from the Census of Agriculture. We can see here a map of all the states and also their names over here. So you can either click here on Texas, or you can look for it here written. So we will select these. And we will access the PDF of table 1, which is what they were asking here. Select your state and then table 1. We will click here. And now we have access to the information, to the summary of the state, and also for each one of the counties. The next part is what kinds of livestock are produced in your AGC8. So we have to find information about livestock and the AGC8. And if we remember, our county was Palo Pinto. So we come back here and we need to find Palo Pinto. So we can do a find. So we can put here Palo Pinto. We can do the search. Okay. So this is on page 37. You can put 37 as well. See, and we have different information about the county. So we have the number of farms, landing farms, market value, the sizes, the amount of cropland, irrigated land, market value again. So you have all these different kinds of information. And if we continue scrolling down, we can see here the livestock and poultry that is available in that county. So again, we were the column in the middle here in Palo Pinto. So we are scrolling down to find the different, what kinds of animals are being, or livestock are being produced in that country. So we have cattle, different beef and cows, and milk cows, I'm sorry. So seems that there are calves as well, hogs and pigs. So there is a variety of animals or livestock that are produced, right? So I think I have yeah, sorry. So we can put here cattle, so cattle and beef, cattle, milk. We had hogs, we had pigs. I think we had chickens as well. Let's see. We have sheep also. Okay. And chickens. Okay, so we have a variety of them. So the next question is to choose one livestock in our AGC8, and then we need to see how many are produced. So we will select one of them. We will start with cattle beef, so beef basically. And we are going to see how many are produced. So we are going to go back to the table, and we have here beef cows. So we have farms and number. We are interested in the number. And we have, okay, we will copy the number of beef cows. Oh, milk cows are not produced, sorry. I will remove this, my apologies. Yeah. How many are produced? So we will put this information here. And the next activity is to convert livestock weight into kilograms. So until now we have the number of animals or beef cattle that we have in our AGC8 that are being produced. And we have here a conversion. This was a table from animals that were produced in Nebraska. So it might be different depending on the states and also on the type of animal, but we will use this for now. So one cow weighs between 550 to 600 kilograms. We have other information for other kinds of livestock. So, okay, one cow and 600 kilograms. So let's see. If we come back here, so we are interested in the weight in kilograms of one animal, and we are going to put 600 here. So what is our formula is doing basically is multiplying the number of animals by the weight in kilograms of each one of these animals. The next question we have is related to the water footprint. And to be able to do that, we are going to access another link, which is bit.ly ag water footprint. You can also find it here in the links in your Excel sheet. So it's the third one over here. So I will access this one. Okay. And we are going to calculate the water footprint for this livestock in our region. And the question is how many cubic meters of water is being used to produce this livestock. And we have the conversion, one liter is 0.01 cubic meters. So once we access this other website, it has information about the different products. So we have the information about the freshwater withdrawals for the production of a kilogram of these food products. So we have different kinds of products. We have cheese, nuts, fish. So you can see the list here. If you're interested in seeing other kinds of food products that are not in there, you can select others. Like if you're interested in coffee, you can select that. So you can select and deselect this information. So we have cattle, so it's a beef, it produces beef. So over here we have the information about how much fresh water is withdrawn for the production of a kilogram of beef. So we have 1,451. So that's what we will put over here. And the formula is already included here. So here we are doing the conversion that I showed earlier. So this is the conversion of 1 liter to cubic meters. So that's here. And then the water footprint, which is calculating, is multiplying the cattle in kilograms by the cubic meters per kilogram for that livestock. So that's the second activity. As you see, students use a combination of resources between Hydroviz and also other web pages. And over here, we can see the responses to the questions and what we did until now. So yes, if anyone has any question, please let me know. Otherwise, we can probably continue with the other activity, with exercise 3. I will wait like a couple of seconds to see if anyone has any question. Okay, it seems that everything might be clear. So I will continue with the next slide. So we are in the third part of the project. In this part, we are trying to learn more about energy production in the region that we selected. So we are trying to see the relation between water and energy. Also, water and land footprint related to the energy production in the region, and the energy production costs. So that's in general what our students would be able to investigate. Again, this is just a screenshot of what you will be able to see in HydroLearn. And this is the third exercise. So in the region, so in our Hackett, we are going to select one plant and we are going to identify its name and what kind of energy does it produce. So we had a little bit of that earlier, but let's go back to Hydroviz just to remember how we did that. Okay, so we had different power plants in the AGC of interest. And over here, if we click here in this information icon, so if you click on it, and you can see the different characteristics of this plant. So in this case, for instance, this plant's name is R.W. Miller. We collected earlier that it produces natural gas. So let's copy that R.W. Miller for now. R.W. Miller here in our Excel sheet. And we have natural gas, so the kind of energy it produces. So the next question, and let me see, okay. How many megawatts does this plant generate? So we are going to continue looking here. And we have 574 as our response. So we will include it here. So also as part of, that's the second question. As part of the third question, we are asking how many acres of land is the plant you selected using? So we identified this table from one of our resources, and you will have access to it in HydroLearn. So we have the different kinds of sources, of energy sources, and the acres per megawatt that are produced. So here for natural gas, we have 12.41 acres per megawatt. So we are going to use that number, 12.41. And that would be our land footprint in acres. here I just copied, we just copied the information from the table, so you have access to it as well. So yes, that's the third exercise for the third part of the project. So as you can see, the students are learning about a lot of different stuff about the region using Hydroviz and these other resources. And I don't know if anyone has any questions, please let me know. Otherwise, we can also move to the other section. Or if you have other questions about Hydroviz in general or some of the exercises, please put them in the Q&A option. Okay, it seems that there are no questions for now. So now I will continue with the next part. Well, here we have the responses to the exercise. And now I will be talking about I will provide an introduction to the systematic decision-making framework that I was mentioning about before. So I have been explaining that our students were learning about the region and this was part of a project. One of the main things that they are instructed at the beginning is that they are presented with a scenario. So they are presented with an issue that has technical components and also social components related to water resources in general, and also about food and energy production. So over here, I just have a screenshot of the scenario, and we will talk more about it later. But they are basically asked to use Hydroviz to try to address this issue. So one of the things that our students learn to do before they engage with this activity is how to use this decision-making framework. And this framework consists on several processes where they are first introduced to a case. Here in the slides, I am just including a case that we used before they start using Hydroviz, so they get more familiar with the framework, with the decision-making framework, where they are presented about a socio-hydrologic issue. In this case, it was an issue related to the disappearance of a lake in South America and what was happening with the population and also with the animals within that region. So then the next step or the next thing that we teach our students about is how to define the problem. So they are presented with different kinds of things related to the issue. So they need to identify what is the problem, what are the causes of that problem, and also what are the consequences of that if the problem persists in the future. They need to define the problem. So they were presented with this lake. So this lake has two main problems. It suffers from water scarcity and also water pollution. Here they explain about the reasons why they have these issues. One is related to mining tailings, and the other one is related to the diversion of a river for agricultural and mining activities, and also climate change. And then I need to define or explain which are the consequences of these issues. So basically, the main consequence is the water scarcity that include the drought of the lake, And there is also the loss of people's livelihoods, so they have to migrate to other regions, and also the death of the different species, animal species, and the loss of their habitat. So this is what they need to put together with all the information they were provided. They need to identify which objectives they want to reach with the solution that they are proposing, and how they are going to evaluate the different alternatives that they are going to suggest to address the issue. So we ask some questions about the things that are most important to them to address this issue. What are the things that they care about? So we help them to transform these important things into possible outcomes, and also to see which could be some potential criteria that they could use to address, to evaluate each of the each of the alternatives. Sorry. So then we also give students this matrix, which is an options versus criteria matrix. So over here, you will be able to see different alternatives to address the issues that they were presented. So one is implementing a treatment facility to manage water resources. Another is closing a mining activity, or providing or improving the mining processes. They also come with their criteria on how they are going to evaluate each of these alternatives, so they can consider financial aspects, also sustainability aspects, no regret options, and they need to then analyze these. So they are going to, if they think, for instance, well, about implementing these treatment facilities, this might be something that is too expensive, so they are going to put maybe they will score it with 1, or for this other option, for this criteria, this option has a better way, so it will have a higher score, and for sustainability, it will only have 2. So then they do that exercise for each one of the alternatives that they identify, and they need to then calculate a total performance score. So for the financial, they initially said, well, this is an important criterion for the evaluation I'm doing, so I will give it a weight of 0.45. So all the weights add up to 1. So it's 0.45 by 1, which is the score that this option had. In this case, for instance, it had a score of 2, so they are multiplying it by 2, and they then need to add the other the weight of the other criteria, multiply by the score they gave, and then they get the total performance score for each one of them. So then they also are able to identify that there is one of them that has a higher score, and in this case is improving the mining processes. Then they need to do an analysis of consequences and trade-offs, and this will help them also to sort of come with a decision. So they also see the different alternatives, and we are asking them about the drawbacks of the options, also which are the trade-offs, which are the options that should be avoided, and what are the best options. So they need to fill more information about each one of these alternatives. We saw in some cases, for instance, that the options versus criteria had a specific total performance score, but once they started responding to additional questions, sometimes they changed some of the alternatives they selected based on further analysis. So here they were able to find that perhaps this option is the one that they need to consider in order to deal with some of the trade-offs. And here they continue reviewing the decision they made. So there are a lot of other questions that we ask. So this is just for them to be able to think further about the different aspects that they need to consider, including what would happen with the different stakeholders that are part of the issue. Okay, so now we are moving into the exercise 4, developing a scenario. So this text is the one that you are going to see in HydroLearn. So this was prepared in a way that you could adapt it for any other scenario that you would be interested in your students to explore. So we start by saying, okay, that students are part of an organization that is in charge of different things. The board of this organization needs to accomplish something. So work towards a sustainable use of water, for example. And they need to reach a general objective, and you can provide additional background related to the case. And here is the role of a student. So here we are telling them what they need to do. So within this context, the students work as analysts or consultants, or you can give them a different role. They are part of this organization, and they have to evaluate the different uses of water and to propose a plan to support the use of water resources, considering different factors, and you can include those factors here. And the next part is, in order to develop this plan, you will need to retrieve data from Hydroviz, sort of following some of the activities or all of the activities that I showed earlier and that are also available in HydroLearn, to evaluate the different patterns of water availability, the resource use, and agriculture and energy in the region. And this is also going to help them to plan or to provide a response to the things that were asked at the beginning of the scenario. So this is in general the characteristics or the description that we give. You can change that. And what I want to show you in the next slide is the exercise that we did with our undergraduate students in 2020 and 2021. So they were presented, this is the scenario that we use. So they were on the OPPD board of directors. So the OPPD is the Omaha Public, oh, I'm sorry. I just slipped my mind. It's the Omaha Public Power District. The OPPD serves Omaha and the surrounding counties, but operates and buys power from power plants across the state. So the board will soon be selecting the new sources of energy for the upcoming phase out of fossil fuel fired power plants, with the goal of converting to 100% clean energy production. So here we have the general objective of the board. This is the task for students. So you are tasked with developing a plan to bring a plan to the next board meeting containing the types and quantities of power OPPD should pursue to meet its energy production needs. So this is the student's task. And your plan must involve a carbon neutral energy options, including these different kinds of energy sources. These are other factors. And these are also some things that they need to consider. So the energy production strategies must match the megawatt hours that are currently produced by other sources of energy or of energies. So this is just an example of something that you can do. We can right now. The question is for you to think and perhaps to share also, like what and to perhaps this is an open discussion now about what scenario would you be interested in developing with your students. So maybe we can take some time to think about this, and if you have ideas or things that you want to share and that we can talk more about, please put them in the Q&A or in the chat so we can sort of visit them. So yes, let's take some time for this. And so these scenarios can be it can vary very much depending on the region and also the interests that you have. We know that some people were interested, for instance, in trying to help their students understand issues related with transboundary water resources or watersheds. So that's something others were using other kinds of cases that, I mean, we're thinking about other cases that could be used. So yes, this is a time for you to put your thoughts on the Q&A. So I will put them here, okay. So one of them is growing almonds, expanding almond acres in production would make a great scenario. Yes, and if you put in, for instance, if you include the region or more information about the region, in California, that can, yes, it's something very relevant for students because it's a produce that is very common there. So that is something very familiar with, for them, and that is important so they can understand. They can understand it better. Thank you. Also, if you have other questions about the decision-making framework, please let me know. We can go back and see perhaps in more detail some of those parts. Again, during the instruction, before students start using Hydroviz for their project, they will learn about how to use the framework in a familiar case and also in this socio-hydrologic issue, but the idea is for them to practice how to use it later. Okay, so the question here is, could you go back to exercise 3 and show how to find the acres in a different type of energy production? Okay, so let me go back to exercise 3. Sorry. Okay, yes. How many to find the acres in the, all right. So the first things we did was we selected a plant, we identified the megawatts, and now we need to find the acres of land. So when we come here, acres of land, all right. Let's see. So when we came here, this in Hydroviz, we were able to find different kinds of information. So we identified the megawatts by, which is this number 574. And we included it here, right? Which comes from the previous question. And then we are asked with the next question about the acres. So we have this table that is available in HydroLearn. It is part of the module where we have these different electricity sources, including natural gas. So the land used by electricity source in acres per megawatt produced. So for natural gas, we have 12.41 acres per megawatt produced. So we include that number here. 12.41, and that is how we were able to calculate. So we had to multiply the megawatts by the acres of land. So that's how we obtained that information. And we have it. Okay, yeah. Thank you. Yeah, I hope that helps. Mm-hmm. You're welcome. I don't know if anyone else would like to share some ideas for a scenario they would be interested in developing. We can see maybe a couple of minutes or. So the question that we have in the chat is, could you use this model to task students to answer a question about whether a given country can meet its own beef or other ag product demand, and how much water and energy is required to do so? Would this make sense as a scenario? I think that your question looks is asking a little bit about water stress, if I'm not wrong, right? So there are some information here in Hydroviz, for instance, that are asking about that provide you information about the different uses of water for agriculture. So that's that can be. I mean, this is more in general for that region. We have one of our questions in our exercises were related to the water footprint. So let's see. So in part 2, we are looking at the water footprint of agriculture. And we saw earlier that we can see, I know that we spoke about beef, you can see about other products as well, about the different footprints. I think that your question also goes a little bit to the demand in the future. So that would be, that might need other resources as well, but I don't know if Dr. Habib, I understand that Hydroviz had some tools that were trying to address some projections perhaps. I don't know if you can help me with that. Okay, I think I will ask him again. But yes, we would probably need to explore that. But one thing would be taking a look at the water footprint and also at the other variables, those that are related with water stress, as I was mentioning earlier. But these are more for agriculture in general in the region. And we have groundwater stress. I mean, yeah, you have groundwater for agriculture. And so I think we can try to, we will need to see the numbers a little bit further about how that could work. Another scenario that we have, so another comment that we have is another scenario would be balancing water use between development, agriculture, and energy in the Ogallala aquifer in the Midwestern states. Yes, yes, thank you very much. That would be very interesting to explore with the students, being that the Ogallala is such an important aquifer in the Midwest. Thank you. Okay, so if you want to continue thinking and sharing, that would be great. We are getting close to the end of the workshop. So we please take some minutes to respond to the post survey. So again, this is important for us as part of the evaluation of the project. And it's one of the requirements also for the grant or the grants. So in part A of this survey, you will have some time to reflect about how you would be using the module. If you need more time besides the time of the workshop, then the survey can be saved and it can be completed later. And if you worry about having access to the responses of the survey, so for your own use, you will be able to download a copy of your responses. So let's take some time to do that. The next minutes. And Julia has shared the link in the chat. Thank you, Julia. Dr. Habib is sharing that if participants are interested in another module that focuses on just energy-water-nexus, they can visit another link, which is heavy on energy. And let me put the link here. That's the link that Dr. Habib was mentioning about. Thank you, Julia. She also shared it. Dr. Habib, there is a question about how often is the data in Hydroviz updated?
Good question. Updating it is kind of a significant effort, but I think the major update here is the water use data, not necessarily the water availability, but the water use, because these data are per sector, ag and domestic and energy and all that stuff. We relied heavily on the USGS national data sets for water use by sector, and these are updated every 5 years. You know, it does require some effort on our part, and we'll definitely try to do it if we have the resources, you know, for doing that. But yes, it's a good question, and you know, how can you keep it updated? Like I said, primarily by consuming the new data from USGS, which we will try to do.
Thank you, Dr. Habib. Well, we got to the end of the workshop. Thank you very much to everyone for your participation. Thank you to Kuasi for providing us this the platform to be able to reach to all of you, and to our friends in the University of Louisiana, also to the granting institutions that were that have been supporting our work. Please let us know if you have any questions regarding Hydroviz or the module. We are more than happy to provide any response to that. Our emails are in the first slide of the presentation. And once again, thank you very much for your time. And I hope you enjoyed the meeting. And please complete the surveys; those are very important. And thank you very much for being with us today. I don't know if Dr. Habib or Julia would like to say anything else.
No, thank you so much. And have a good rest of your day, everyone.